my favorite slot in the day right after lunch. How was it? Thumbs up? Hey, that's 80%. Oh, somebody is not happy with it. Okay. My name is Markus, not Mirko, but you actually don't have German names on the Coca bottles. So anyway, I thought about getting you up to speed again. So you're obviously interested in continuous delivery and Docker. And I'm obviously going to talk about that a little bit. Who actually is using Docker in production? And just don't raise your hands. Stand up, please. Just two? Okay. Who's actually working with Java EE? Come on, stand up. I want to wake you up a little bit. Come on. Okay. That's funny. That's 4 people. The main topic of this talk is exactly around those 2 things, and it's not going to be like an entry level, so I'm not going to talk about what Java EE is. Basic assumption is that you know about that. But fair enough. What am I? What am I doing? I'm working for Red Hat as a so-called developer advocate, which is kind of a funny blog title, but I'm using it as my main title. And I get to play with all kinds of fancy new technologies in my daily life and do some kinds of thought leadership and to show you what you can do with that recent kind of technologies that everybody is talking about, but obviously nobody is running them in production so far. So let's see. I have to admit I'm a Java EE guy. I've always been a Java EE developer, and I really, really like the platform. It's pretty easy to get started once you learned all the different specifications, and you know how things behave typically. So I've been running millions of Java EE projects. No, not millions, maybe 350 in my 14 years as a consultant in the field. And we've been doing large installations with Java EE. And I have to admit, it's always been enterprisey settings, like Fortune 500 companies, 2 million lines of code, like the real big heavy hitters. And even right after I left the consulting field, things turned over and business decided to require new features more quicker. And probably most of you know that having like a 5 to 10-year-old code base and somebody in business asking you to implement a teensy little change somewhere or a big new feature turns out to be a medium nightmare very quickly. So Java EE and especially those enterprisey settings, we learned a lot over the years, right? And catching up with the business has been a challenge lately. What did we do traditionally? Typical assumptions. Come on. Funny. That shouldn't happen. Oh, that was a free. Now we're talking. He's just too slow for me. I'm actually downloading something in the background for you to show later. So, software should never break, which a great entry to that slide when nothing worked. Production environments needed to be provisioned. Like in my former company, we had a great service, like an intranet website where I could just put in some project details and hit submit, and a ticket was generated to operations. And this ticket sat there for like 2 weeks. And I was waiting for my new infrastructure. Might have been a test server or stuff like that. Okay, what else do we have? Deployments, typically around Christmas, right? 24th. Everybody is keen on going home. Everybody checks in latest changes. And we're going productive, right? We have all the new Christmas features in place. So, yeah. Production environments, like SSH to a production instance, never done that. Ops things, right? So applications tend to be very separated between development and operations. And even a little bit more. I mean, there's been these nasty little guys who have been testing my code, like checking if features work like expected. That was unfunny. Okay, the kind of 3-layer separation in traditional development and enterprise settings was I was focusing on writing code, which should fulfill some requirements. Somebody was testing it during the turn of the life cycle, and another guy was putting everything into production, and of course monitoring it, right? Because typically what happens when an application moves into production, into critical load? 15 minutes, right? The average when it first comes down. Anyway, ops should focus on preventing that. But seriously, this is so yesterday. This is something nobody really wants to do, especially not waiting for tickets to be fulfilled by operations or whatever. So we need something else. And the key to that is often referred to as continuous delivery, right? We want to have like a complete cycle. We want to be shipping production-ready releases frequently, often. We want to be 100% automated, so nobody really has to put its hands on a release anymore. It should be literally just a button click away from being in production somewhere. And of course, the whole application development setup, like development environments, test environments, staging environments, should also be like accessible at a snip. I want to have a complete self-service. If I'm working in a project and I decide to have a new test instance, I should be able to spin up one, right? And if we really fail somewhere, that failure should be discovered very easily and quickly, like we have automated testing. We really need to have one thing for that, which is a really fast redeployment and build process. And this was something that didn't really fit into Java EE, but we learned to make it happen. Traditionally, putting applications into productions went comparably like that. You had some product teams, and they did kind of the full stack mingling around with all the other cross-application units. Today, if we're thinking about smaller applications, maybe somebody heard the word microservices before, we like to think about that a little bit differently. So looking at applications today, this is what we really want. We want to be responsible for the parts of the infrastructure that are middleware and application-centric. And to me personally, that even ends before the database. But at the end of the day, it is okay if I am able to influence the complete middleware stack, including the database, and don't have to mingle around with everything in the infrastructure. And if I could make a wish at that point, I'd like to see kind of an API in between, something that I could just program against, maybe even have some automated health check capabilities or something like that. But the biggest issue here is that a traditional architecture just doesn't fit into that picture, at least not nicely. It's all been in one box. Name it whatever you like, JBoss EAP, Wildfly, or one of the others we're not calling by names. If we wanted to scale those applications, the Java EE approach to it was typically scaling a complete stack. And this is where, back in the days, virtualization came into the game, right? So we had our virtualization images, and we could just put one next to each other. They contained the complete stack. Maybe we deployed our application into it later on. But that's been pretty much it. How's this going to look tomorrow? Maybe like that. Has somebody heard about Wildfly Swarm? Well, okay, one. This is a nice little teensy project. If you are sick of really big Java EE servers and you're really looking into something which fits your needs a little better, like you only want to have, for example, two specifications like CDI and JAX-RS, Wildfly Swarm actually was built on top the core modules of Wildfly and rips everything apart and lets you basically reassemble it together based on your needs. So you don't have to always use the full-blown application server. You could just do something custom and still have all the Wildfly performance and advantages in there. So we have our individual application parts on maybe those teensy little runtimes like Wildfly Swarm, or we have a single REST service on a JBoss EAP server somewhere. But how do we provision those? Back in the days, Java EE application server platform decisions by customers has been made. We had one template. We knew exactly what we wanted to have as an infrastructure, as a middleware infrastructure. We didn't have to think about that. And now maybe someone else comes across and says, I want to run a Node.js application. Not talking about Node.js at that point, but maybe let's say Vertex. It's also nice, Java-based, fits the microservices programming model a lot better. So what do we do with that? Like, we're starting to mix middleware infrastructures and technologies. There's literally one very good idea to make that happen. And this is containerizing everything that you have. So you basically put all your instances into container images. So it doesn't matter to the underlying platform that you have, either if it's on-premise in your basement, if it's something like a virtualized system, or even a platform as a service. As long as it can run those images, it does no longer matter what's in there, and you don't have to care for that. So, and there's another advantage, actually. How do we scale this as an application? Like an application broken down to individual services? We don't have to scale the whole box anymore. We can actually scale on demand. So if we recognize that we have a bunch of Wildfly services that are in high demand and that many people are using, we could just scale this part of the application and make it available. We've been talking about something that I like to call the modern pyramid of enterprise application development. This is more or less the problem space that we all will have to handle in the next couple of years. This is not I'm not trying to scare you away. This is something that's more or less on the horizon, because a lot of operations actually go down that road as we speak today. Who's using Amazon services, AWS-like? Okay, 3, 4. So a lot of companies been looking into infrastructure as a service and platform as a service offerings like OpenShift Online, for example, also gained a lot of attraction over the years. So this is kind of rolling out broadly. And with the advent of containers, we really have a chance to run whatever piece of software we have pre-configured on whatever platform we wanted to run. And believe it or not, Docker support is also coming to Windows Server. So if you have a JBoss EAP running in a Docker container, you could probably easily run it on Azure sooner or later. So you don't have to decide about the underlying platform. This is a lot easier in terms of sourcing and scaling. And it is going to come. Let's talk a teensy little bit about microservices. I don't know, but I think there will be applications who will profit from microservices. So this is another thing that you will have to handle sooner or later. And DevOps, who's working in a DevOps team as a setup? 3 to 4 to 5, does it work? Do I see people smiling? Yeah, right. It's a lot of responsibility. You're responsible not only for your code. You don't have to drink a beer with the testers to get your green approval light, right? Because you are the tester. You make sure that the whole application is developed, tested, and staged into production. So DevOps is a really great team-building effort. And I think this will also spread a lot more broadly, even if I've been just a year back still working like in more agile-driven teams, still very much separated from the operations. But even that, I mean, the advantages are pretty clear, and I think we'll see a lot more uptake on that in the future. Okay, and the poor Java EE developer, what's in it for me? I said DevOps might be a team thing, responsibility comes back, brings a lot more fun into the daily life, so that's a good thing. But at the end of the day, we can refocus again on our applications, right? So we have standardized environments that we can work with. We can basically use them as containers as we speak, and we can spin up those instances in literally seconds. So this is a lot easier in the day-to-day handling. And images actually can be centralized configured. So you could have somebody like in central IT or whatever who defines how exactly those images look like, where your Java EE application server is located, how the data volumes are shared or whatever. So you don't have to mingle around with infrastructure that much anymore. And according to the Docker slogan, build, ship, and run any app anywhere, this is exactly what containers look like. So at the end of the day, it's a lot more faster, a lot more predictable delivery of your applications. I'm not convincing, right? What's so great about containers? Everybody's speaking about them. Who's played around with Docker? Okay. I have a thing in my talks. So whenever I am speaking, I'm totally aware that 60 minutes don't cover everything, even 45 plus questions. So I have kind of a homework assignment for you. If you're interested in that, and if you want to understand what containers are, take the minute afterwards, maybe evening hours, whatever, you find a free minute, and educate yourself a little bit about that. It's really funny to play around with containers. And as you've seen, I'm running Windows, so there's a reasonable Docker support for Windows also. So there's literally no excuse to not put your hands on the first Hello World example and understand a little bit. Okay, containers are great because they are completely standardized boxes. You don't have to look into the kind of application that you want to distribute. Remember, like EF files, like the build process, WAR files, tons of configuration stuff. We set that up and we deployed it. We had a lot of configuration in the app servers. We had a lot of configuration when it came to databases or whatever. If you really have everything configured once in a container image, you can totally forget about that, and you don't have to mingle around with that anymore, because it's done once and not at all anymore. And if a container breaks, the good thing is it's immutable. So you could just use a new one. If you mess something up, delete the container, start over from a scratch image. That's pretty easy. What could be drawbacks? Maybe standardization has a drawback because one size obviously doesn't fit all requirements. So there will be still some requirements which containers can't solve. And containers can be tricky beasts. They have versions, and we can pretty much make everything, but we've all seen those fancy container ships fail. So some things can actually go wrong. And the most critical part actually is if you start to look at containers like square boxes, this might be the biggest mistake. So there's a lot of technology and infrastructure in there, and this is the call for action again. Just educate yourself a little bit. What I find mostly scary about it, all of that, I'm not in control anymore. There is a hell lot of magic going on. If I just type something like Docker run JBoss wildfly, something happens. I get a complete instance of Wildfly downloaded. It starts on my machine. I haven't done anything to it. It's kind of pre-configured, and that's scary. I don't know where it is in my file system. I really need to look into it, and I don't know how the networking works. So there's a lot of magic going on in containers that you really have to try to understand. Container deployment. My first question was who was using it in production, so that's okay. Don't feel guilty for it. Not many organizations use it as of today. It is something that requires a lot of preparation. But the first proof of concept teams are out there and they're working on it and they get it into production very efficiently. And at the end of the day, you still need to look after containers. I mean, they still contain an operating system, even if it's a small layer. They still contain your application server, and you need to take care for everything that you would have done in virtualized infrastructures, for example, like security patches or updates whenever necessary, right? There's even a JDK in there. And if you want to update JDKs, you probably have to come up with a new container image version. I think the success factor here will be to minimize the versions that you're running in your enterprise. And there's even more. I mean, containers can be totally abused and totally screwed up in every situation. So it makes life a lot easier if containers are immutable. So the throwaway kind of culture that we are all accused of living in kind of found its way into our industry at that point. And it might get complex. So containers running independently somewhere need to talk to other containers. And there's networking involved. There are shared folders involved. There is kind of communication involved. And at the end of the day, you also have to administrate those containers. And you won't get that going in production scale without any kind of orchestration tool at that point. I brought you something just to show you a little bit. It's not the only one, but it's the best one, obviously. Just the name is OpenShift. We have 3 different editions of it. The one we're talking about today is the open source project Origin. So whatever I'm going to show you today, if I'm going to show you something, curious, you could totally play around with that and get that up and running. I have a bunch of blog posts on my blog about how to get started on Windows. The OpenShift documentation itself is pretty good on Linux. So just go ahead and try it out. There's nothing, no license fee, it's open source. If you really want to play around with it without installing, like having it run somewhere, then OpenShift Online is your go-to. Little drawback, we're talking about the next version, which just got released, the V3, and this is not available in online as of today, so maybe later. And if anybody wants to buy subscriptions, then the enterprise version is the right one to look at. Why OpenShift? Because Docker is just shitty hard. That's the truth. It's easy as long as you're running a simple Hello World container, but if you really want to start scaling containers and running more than one and do a little bit more monitoring and be a little bit more production ready, then you're literally at the end of what Docker can do as of today. Plus, it would be helpful if an orchestration tool actually not only knows how to technically do that, but also support its users by doing it. Self-service-like stuff. What do I like the most about OpenShift? I think I can run it on Windows, which is pretty cool. I tried to run Kubernetes on Windows, which it's another orchestration approach at that end. I failed gracefully. Yeah, I'm a Windows guy, so OpenShift is pretty pretty complex and still has a reasonable abstraction for everything. I'm going to walk you through a little bit. Also nice, you can deploy it wherever you want to. So whatever I'm going to show you locally runs on my machine today. It's 16 gigabytes, 8 cores, so it's a little bit bigger, the machine, but still, it's possible. But even if OpenShift is kind of exciting, and you can do a lot of things with it, it's not enough for me. Because seriously, I don't want to look into networking. I don't want to know about all the nitty-gritty details about container and orchestration and pods and controllers and services and exposed ports and whatever. So I don't want to mingle around with configuration files. It does a good job, but it knows nothing about me as a Java EE developer, and I don't feel valued. Seriously. And it doesn't know about tools I know about. I care about Maven. I know how Jenkins works. This is how we did continuous delivery before all those container stuff came up. Why not now? Why should we reinvent everything? I like Sonar, and I'm totally happy if I have a Nexus repository somewhere, right? So why doesn't know OpenShift about all of that? Because they don't care. It's an infrastructure component designed to run containers and not Java EE middleware. To the rescue, I have something which is called Fabricate. And this is exactly what we've been looking for as Java EE and middleware developers. We really want to use a DevOps platform that knows about our requirements. This thing, this project, brings together all the technologies that we used until today and that we want to use in the future. It knows Jenkins. It knows Achillean for integration tests. It cares about everything that needs to be defined or written, JSON files, whatever, for Docker and Kubernetes. And I don't have to mingle around with that. And it even has some cool Maven plugins. I could just put like a 5-line plugin definition into my standard Java Maven project and generate a Docker container with all the required dependencies. I didn't even have to do anything else fancy. So no Docker files or whatever, just a Maven plugin. And this is exactly what I like. So this is where a Java EE developer starts smiling, right? Because it cares about our tooling. And I'm not saying I don't want to educate myself any further, but I don't want to make my life harder than it already is, right? So what I do appreciate actually is that it integrates tightly with OpenShift at that point. It's not the only one, but it's easy to use. I heard somebody that it's also running on Google Container Engine. So how does a tooling stack today look like? This could be it. We have like a basic Linux host, of course. Project Atomic is pretty cool because it's very, very thin and lightweight. We swallow Docker's container format because it's kind of a solid standard that we really want to use. And Kubernetes is the de facto standard for container orchestration at that point. So on top of that, we're putting a little bit of OpenShift, a bunch of APIs, and call that infrastructure user experience, making platform as a service even cooler. And when we look into developer experience, this is exactly what Fabricate does, like abstracting everything below it away from us and just letting us work. And looking back at one of the slides, this is the API I wanted to have at that point, right? So I really want to have those two tools at hand to work with them and make my life as a Java EE developer in that container, I'm not calling it hell because I actually like it, but in that container mystery cloud thing working. Okay, let's see what we have. A demo, hopefully. I'm not convinced, but I try my best. I have a backup, so don't run away. What I'm going to show you first, and this is going to be a little bit nasty, is actually OpenShift. So this is OpenShift origin, running a bunch of containers on my local machine. Origin knows something like project definitions. We have a default project here which hosts a Docker registry. This is something that you need to look into when you educate yourself about Docker and containers a little bit. You see another service running, which is Fabric 8. This is what we're looking into later, and a bunch of other services that I already started. So you could browse through everything here. You can see the individual pods, like the OpenShift internal IPs and the exposed services, also, which are mapped through a router to external accessible services. But this is by far nothing a Java EE developer really wants to look into. So what we want to see is Fabric 8. Come on, there we go, cool. So this is Fabric 8. You have to admit it looks comparably similar, I agree. Let's see if my Jenkins, it's still not there. Doesn't look good for my demo today. So Jenkins is still downloading its image definition, but at least I can show you a little bit. So this is the overview of our services, and as you can see, there are things that are comparably familiar, right? So we have Jenkins, we have Gogs. Gogs is something like GitHub, just running locally on my machine. Okay, so there are no repositories here right now, which is fair. We'll look into that a little bit later. I should make it a little bit easier for me. Let's see if that works. No, I'm not. Okay, so we can see all our service controllers and pods and whatever. So this is still infrastructure, right? And nobody really wants to see that. What we want to talk about are actually projects, Java EE projects with source code, right? So we have something here. This is called, you should have done your homework, Markus. Let's log into Gogs and create a new project. So this looks a little bit more familiar, right? So we want to give it a name. Let's see, my sample. And we take that name and copy it over and also make that the final name. And we actually want to have a project which is derived from a Maven archetype catalog at that point. So let's see. There's a built-in catalog which is called Fabric 8, and they have a bunch of demos in here. One of them should be a Camel CDI demo. I've been playing around with Camel a lot lately because I just like it as an integration framework. So let's see what happens if we execute our project definition. That shouldn't take too long. What's actually happening at that point is that a complete source repository is published in the dashboard. Come on. I did that. It was comparably fast. Okay, we derive that image from, let's say, Tomcat. Sounds pretty fair. This is actually the Docker image that we want to build our application on. Tomcat is okay. You've seen that we could also easily use Wildfly at that point. We want to also include test dependencies because the project we're looking at contains an Achillean test. We don't want to have an icon. You can assign groups and labels to make it easier identifiable, and you can also name the container. I'm just using my nickname here. And again, This is self-service, right? This is setting up your project. This is setting up your Git repository. This is setting up all the bases for the container build process that you want to have done without actually mingling around with configuration files. And the funny thing is, now you see that a project, my sample, actually got created and pre-populated with that example application encapsulated in that archetype, right? So this looks pretty familiar. I didn't do a lot, right? No command line, no nothing. It was all browser-based. This is exactly what Fabric 8 is doing. And he's still executing. It might be that I have to stop at that point because of my missing Jenkins dependencies. What else could I show you? You have seen that we do have some more services running in Fabric 8. One of those is the Nexus, which has an empty catalog right now because we haven't started building anything yet, which isn't something we're anyway not going to do, so there's nothing to show here today. Fancy. Good news is I have a recording of the demo, and I'm going to include it in at least as a link in the slide deck, so you could re-watch it. I'm not going to show you Jenkins at that point. Okay. What else do we have? Fabric 8 is still working, so we're not going to wait longer for that. So much to my demo parts. I don't want to play that demo right now. It doesn't make any sense. So you'll have a good chance to work your way through it. What else do I have? I have some more resources for you in terms of homework. I still like that a lot. My blog is kind of a gold mine for playing around with Fabric 8. I blogged about the Maven plugins and how to use them and how to integrate that into your builds to make it easier. I blogged about how to make Wildfly running on OpenShift via Fabric 8. And I even did like a little play around with some other big application servers that nobody ever thought could be running on OpenShift. But I did it, at least for playtime. I made a WebLogic run on OpenShift. So this is the good point in container images, right? As long as there is a container definition somewhere, you could basically run everything everywhere if you know how to make that work. And I also have kind of a handy guide. This is the last link in that slide about all kinds of JBoss and Docker and Java E related things. If you want to follow me, you could do that via Twitter on MyFear. JBoss Developer is our open source Twitter handle. All kinds of news around all relevant projects, including Fabric 8.io. And I have a nice pitch and lookout for you. This is kind of coming. I think in October, might be Java 1 or OSCON Europe timeframe, will be a little teensy book, roughly 70 pages, and should contain a lot about how to migrate Java EE applications into microservices, how containers and DevOps fit into that picture, and will be available for free, so you might want to check that out when it's there. The demo brought us a little bit time, but anyway. Questions and answers, if you like to. Into what? Into containers? Can be easy. If there's a container, it literally doesn't behave differently than an instance running on your machine. You just have to make sure you expose all the management ports. So you could use a local command line for Wildfly and just deploy into the container. So easy. If you have to build something from scratch, it might take a little while. Honestly, the thing that I found most disturbing is getting into the new language for containers. Learning about file system layerings, learning about networking. I've always been mingling around with that things, but on physical machines. And it's totally different because Docker completely encapsulates an internal network, the Docker daemon, and only exposes services when you want them to be exposed, right? And this is a variety of abstractions that made it comparably hard for me to at least get a gist of it, something as a base to start off. It's different. It's a lot more detailed. Yeah, it's bleeding edge still, I guess, at the moment. A lot of people playing around with that. What I've seen actually is that many people were waiting for a platform like OpenShift, something to make those new images and container technologies handable, like usable. And with the advent of all those platform as a service / infrastructure base operating systems, we will see a lot more uptake. Right. This is actually something you can do as of today. You have two different options. You could link an external file system, which is not going to be destroyed when the container comes down, or you could layer your images accordingly and layer a data container into it and make the MySQL container use the data container. Different approaches, but possible as of today, yeah. But yes, yeah, I mean, it's basically the same for all kinds of information, like log files. What do you do with log files in such an environment? OpenShift makes at least sure it collects everything centrally, right? So people have been waiting for exactly that kind of management base to make that handleable. Thanks a lot.